Assalamu alaikum everyone. So today we are going to study about molecular and empirical formula. So we should know what's the difference between a molecular and an empirical formula. The difference is that a molecular formula shows the actual number of all the elements which are present in a compound, whereas an empirical formula gives you only the simplest ratio between the atoms of different elements which are present in a compound. Okay, so that's the major difference between a molecular formula and empirical formula, that a molecular formula gives you the actual number of all the atoms which are present in a compound, whereas empirical formula gives you the simplest ratio of all the simplest ratio between the atoms of elements which are present in a compound. Now you can understand this with the help of different examples. For example, in benzene, the molecular formula of benzene is C6H6. C6H6, that means this compound contains 6 atoms of carbon and 6 atoms of hydrogen. So that's the actual number of carbon atoms. This number 6 is representing the actual number of carbon and hydrogen atoms which are present in its molecule, whereas the empirical formula will give you the simplest ratio between carbon and hydrogen atoms. What is the simplest ratio between both of them? It's 1:1. So that means the empirical formula for benzene would be CH, giving us the simplest ratio in which these two atoms have combined together. Next is glucose. The molecular formula of glucose is C6H12O6. It means that in the molecule of glucose we have 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. But if you take the simplest ratio between carbon, hydrogen and oxygen, then it would be, now you can divide. For taking the simplest ratio, you have to divide with the smallest number. So the ratio would be 1:2:1. Then the empirical formula of glucose would be CH2O. That's the empirical formula for glucose. Now next example is of hydrogen peroxide. Hydrogen peroxide has a formula C2H2. Just like benzene we had C6H6. The simplest ratio between hydrogen and oxygen over here is 1:1. So the empirical formula for hydrogen peroxide would be HO. Now if you take water or you take carbon dioxide, over here the ratio between hydrogen and oxygen is 2:1. So further you cannot simplify it. So that means water has the same empirical as well as molecular formula. Same goes for carbon dioxide, because in carbon dioxide again the ratio is 1:2, which you cannot further simplify. So water and carbon dioxide, they both have same empirical as well as molecular formula. Now let's see what are the rules for writing the empirical formula. Step 1 is that you have to write the masses or the percentages, whatever is given in the question. If you are given percentages, then you have to assume percentage as 100 gram. Percentage means out of 100. So assume it to be 100 gram, then the percentage values become masses in grams. Like for example, if you are given in the question like carbon is 40%, so that means that carbon will have a mass of 40 gram. Hydrogen is 6.7%, so that means hydrogen ka mass would be 6.7 gram, and the mass of oxygen would be 53.3 gram. So is it clear now that we have to assume percentages as mass in gram? In the next step, what do? You convert masses to moles by using the formula for moles. That mole is equal to How do you find moles? That mole is equal to mass in gram over AR. AR is the relative atomic mass that you can find from the periodic table. Next, when you calculate all the number of moles, then in the third step you have to find the simplest ratio, or you can say the mole ratio, by dividing all the moles that you have got by the smallest number of moles to find the ratio. Okay, and when you have got these ratios, check that these are they must be in whole numbers. If they are not, then you have to round them off. This is an easier way of rounding them off. Like if, for example, if your answer is like 1.5, or it's in fraction, like it has 0.5, then you can round it off. You can round off by multiplying it with 2. If it is 0.33, then you can round off by multiplying it with 3. If it is 0.25, you can round off by or change it into whole number by multiplying with 4. And if it is 0.2, then you can round off by multiplying it with 5. Okay, and then after you have got these values in whole numbers, then you have to write those numbers as subscripts in order to get the empirical formula. All right. Now, when you have got the empirical formula, then you have to find the molecular formula from it. For writing the molecular formula, what is the first step? The first step is that you have to calculate the empirical formula mass. Then in next step, you have to find the value of n. What is n? N is a whole number, and this is the formula for finding calculating the value of n. That n is equal to relative molecular mass, which is mr, divided by empirical formula mass. So this is the formula to calculate the value of n, and once you have got the value of n, you will multiply it with empirical formula in order to get the molecular formula. Okay, now let's solve an example. Here in the example, it's written that a compound contains 40 gram of carbon, 6.66 gram of hydrogen, and 53.3 gram of oxygen. So first of all, write the elements which are present in which are given in the question. All right. So you have carbon, you have hydrogen, given hydrogen, and the other element is oxygen. All right. Next, what was the first step? First step was that you have to write their masses. What is the mass of carbon given to you? It is 40 gram. Hydrogen is 6.66 gram, and oxygen is 53.3 grams. Now let's move on to the next step, and the next step was that you have to find moles. And how do you find moles? You will divide mass by AR. AR, atomic mass of carbon, is 12. You can get it from the periodic table. For hydrogen, it is 1 divided with 1. For oxygen, it is 53.3. So divided with 16. Calculate the answers. The answer would be 1. It would be the answer would be over here. It is 3.33. Over here it is 6.66, and here it's 3.33. Let's move to the third step. And what was the third step? Third step was that you have to find the mole ratio, or you can say the simplest ratio. And how do you do it? You divide it out of these three, check the smallest number and smallest number of moles, and divide the whole equation with it. sorry, not the equation, divide all these with that smallest number. 6.66, 3.33, you will divide it with 3.33, which is the smallest number, to get the simplest ratio. Now the answer that you will get is, for this it will be 1 and 2 and 1. Alright, now you have to write in the fourth step. We will get the empirical formula, since all of these three values are in whole numbers. So now you can write them as subscript and you will get the empirical formula. Write these values as subscript. The subscript of carbon would be 1, the subscript of hydrogen would be 2, and the subscript for oxygen is 1. So this is how you will get the empirical formula. Okay, so with the empirical formula is CH2O. That's the empirical formula. Now as we are also asked to calculate the molecular formula, now we have to move on to the molecular formula. For that, first of all, let's calculate the empirical formula mass, or you can say EFM for this. It would be, you can easily calculate the atomic mass AR of carbon is 12 plus hydrogen is 1, the subscript of hydrogen is 2 plus oxygen is 16, subscript is 1. When you add all of them, your answer would be 30. Alright, and what is the value of MR given in the question? It's over here. The relative molecular mass is 180. The value of MR is given in the question, and it is, the value of MR is 180. Okay, now we just have to find the value of N, and it is MR, it's equal to MR divided by empirical formula mass. Just put the values in it. Empirical for molecular mass is 180 divided by 30, so your answer would be 6. So that means the value of N is equal to 6. Now we have to find out the molecular formula. That molecular formula is equal to N multiplied by empirical formula. Empirical formula. The value of N is, we have just calculated it, 3. That means 3 molecular formula would be 3 multiplied by empirical formula. What was the empirical formula? It was CH2O. When you multiply it with 3, the molecular formula comes out to be C3H6O. Sorry, the value of N is 6. Now the value of your molecular formula would be C6H12O6. Okay, that is your molecular formula. Okay, now let's move on to the next question. It is that 36.3 gram of sample of a compound contains 14.4 gram of carbon, this much gram of hydrogen, and this much chlorine. So that means we will write over here carbon. We are given the mass in gram of carbon, hydrogen and chlorine. Okay, so write their masses, follow the same steps. You have to write the masses. Mass of carbon is 14.4. For hydrogen it is 0.600, and for chlorine it is 21.3. Now we have to find the number of moles for three of them by dividing with their atomic masses. So it would be 12. For hydrogen it would be divided by 1. For chlorine, the atomic mass of chlorine is 35.5. You can check from the periodic table, and your answer would be, for this one it would be 1.2, it would be 0.6, and for this as well the answer is 0.6. Next, what do we have to do? We have to find out the simplest ratio, or you can call it the mole ratio, by dividing with the smallest number, and the smallest number is 0.6. So divide all these three with 0.6. Divide by 0.6. Now when you divide it with 0.6, your answer would be 2:1:1, and then we have you will get the empirical formula, which would be C2HCl. Now again you have to find out, we have to find out the empirical formula as well. The relative molecular formula of this the relative molecular mass of this compound is this much, and you have to find out the molecular formula. So for that, first of all, you have to find out the empirical formula. Mass, it would be 12 multiplied by 2 plus 1 plus 35.5 for chlorine, and your answer would be 60.5. And then what do you have to do? You have to find the value of n. The value of n is, you can calculate it by using this formula. The value of MR, relative molecular mass, was given 181.5 divided by 60.5. Your answer would be 3. Here the value of n is equal to 3. Now you have to find out the molecular formula. Molecular formula is equal to n multiplied by empirical formula. It means it's 3 multiplied by the empirical formula was C2HCl. Alright, so the molecular formula would be Cl3. Okay. Now next one is that an oxide of phosphorus contains 43.7% by mass of phosphorus. Over here they have not given the mass in grams. So what will you do? You will write percentage as mass in gram, and it is written for only phosphorus. What would be the other element? Since it's an oxide of phosphorus, so that means the other element would be oxygen. Okay, so just write the mass of phosphorus as 43.7 gram. as it's given in the question. Now what about the mass of oxygen? As we have taken its percentage, okay, so percentage means that the total is 100. Whenever you take the percentage, in a percentage the total is always 100. So out of 100 you have 43.7 gram or this much percentage of phosphorus. So remaining would be oxygen. So how much it would be? It would be 100 minus 43.7. So subtract it from 100 and you will get the amount, the mass of oxygen, and it would be 56.3 gram. Done. Then again the next step, you have to calculate moles. For moles you will divide the mass in gram with the atomic mass. Atomic mass of phosphorus is 31 and for oxygen it is 16. So it would be 56 divided by 16. Calculate it and you will get the answer as 1.41 over here, and for this it would be 3.52. Now the third step is that you have to find the simplest ratio by dividing with the smallest number, and when you divide it, the smallest number is 1.41, so that means you will divide with 1.41. Now here when you divide, you will get the answer for this one, and here you will get 2.5. Now here you can see that this ratio is not in whole numbers, so that means you have to convert it, you have to round it off. All right, and I just told you before that you have to multiply all these ratio with any suitable number so that you can round off easily. All right, like this I've told you here. So this is what we are going to do now. See, for phosphorus and oxygen, the ratio that we have got over here is 1:2.5. all right, and we need to round it off. So if we multiply both of them with 2, so your answer would be 2:5. So that means your empirical formula would be P2O5. Clear? So it was given in the question that show that the empirical formula for this oxide is P2O5. So you have proved that the formula for this oxide of phosphorus is P2O5. Now let's see the next part of this question. Part 2. In the part 2 it's written that the sample of this oxide has a mass of this much, and the sample contains 0.00901 mole of the oxide. Calculate the relative molecular mass. It means they have not given the value of MR. We have to find that, and then we also have to find out the molecular formula for this oxide of phosphorus. All right, so here first of all we have to calculate MR. And how can we calculate MR? We can calculate it by using the formula of moles, and it was moles is equal to mass in gram divided by MR. That was the formula. You can rearrange this formula to calculate the value of MR. After rearranging it, you will get MR would be equal to mass over moles. Okay, and now let's move back to the question. What is the mass they have given in the question? It is 2.56. And what is the number of moles given over here? The moles are also given over there. We'll just put in the values. It was, mass was 2.56 and the moles are 0.00901. Divide it and you will get the answer 284. So the value of MR is 284. The other thing is that we have to find out the empirical formula mass. Empirical formula mass as well of for P2O5. It would be 2 multiplied by 31 plus 5 multiplied by 16. That means 62 plus 80 and your answer would be 142. Now you have to calculate the value of N by dividing MR with the empirical formula mass. It means 284 divided by 142. Your answer would be 2. Now you can easily calculate the molecular formula. That molecular formula is equal to N multiplied by empirical formula. The value of N is 2. And what was the empirical formula that we just calculated? The empirical formula was P2O5. Just put the value over here, P2O5, and then you will get the molecular formula P4O10. So that's your molecular formula for this oxide of phosphorus. I hope this concept is clear to you. See you next time. Allah Hafiz everyone.